graph linear functions when they're in slope-intercept form and when they're not in slope-intercept form. So this is page 205. And we'll talk about graphing horizontal and vertical lines, and we'll write equations from graphs. So all things slope-intercept related. I hope that it seems like a review. We've been doing a little bit of this work already. So remember that M is the slope and B is the y-intercept. That's all you have to remember to plot these lines. All right, so let's just practice first identifying the slope and identifying the y-intercept for each of these. Let's write our slope as a fraction. So if I was going to write part A as a fraction, I could write 2 over 1. So for slope, you always need a rise and a run. And then the y-intercept is at 3. So what do I do with that information? My first step is find the y-axis, that's the vertical axis, and put a dot right at 3 on the y-axis. Then you do your slope from that point. So in this case, we're going to rise 2 and run 1. So I go up 2 over 1. I'm going to do one more point, down 2 over 1, so I have a few dots to connect. Domain and range for any line. So is the line going either direction, left and right? And is the line going either direction, up and down? Yes, I can plug in 0, a negative number, a fraction. I've connected the dots. So we say that the domain and range for linear functions are all real numbers. So that double vertical line, capital R, represents all real numbers. I can plug in any y, or I can plug in any x, and I can get any y. That's not true of all functions, but it is true of linear functions. All right, what about b? What is the slope in b? It's kind of missing, isn't it? So the number that I could slide in there is a 1x. So I could write my slope as 1 over 1. I'm going to rise 1 and I'm going to run 1. And then my y-intercept is at -2. All right, so I'm going to start this time at -2 on the y-axis. And I'm going to rise 1, run 1. So this is also a positive slope. I guess I kind of gave you 3 positive slope lines, which I should have given you one that was negative, but I didn't. All right, domain and range are always all real numbers for linear functions. All right, and what about the last one? The slope is 1/2, and the y-intercept is at 6. So see if you can take a second and graph C on your own. Plot 6. Oh, shoot. All right, let's troubleshoot here. Here's my 6. I would have gone up 1 and over 2. So can I go down 1 and over 2 in this direction? Down 1 and over 2 in this direction. So I can kind of make it work. Right? Just do an imaginary 6. And then the slope would have been 1/2, but I can't really go up 1 over 2, so I'm going to go down 1 over 2. New worksheet. So note to self, I should put a negative in there for next year, and I should adjust my y-intercept. Negative and y-intercept for next year. All right, domain and range are all real numbers. Can I turn the page on when it's in slope-intercept form? That feels familiar enough. All right. So let's do some graphing when it's not in slope-intercept form. All right, well, our goal is to put it in slope-intercept form. So I need to get y by itself, so it's y equals mx plus b. So what would be my first step to get the y by itself? Well, can I move to the other side? I'm going to move the 3x by adding 3x to both sides. These two are not like terms, right? This is a constant and this has an x. So I have 2y equals 3x plus 4 as my first step. Question? Oh, you're going to give me the next step? Okay, what's the next step? Yep, and you have to divide every single thing by 2 when you do a division problem. All right, so I get y equals 3/2 x plus 2. Now I should know how to graph that. The hard part was getting it in slope-intercept form. Once it's there, you should now know how to graph that. So we're going to start at 2 on the y-axis, rise 3, and run 2. So again, a positive slope. I promise one of these is going to come out negative, I hope. Maybe it's not. None of them came out negative. I must like positive numbers. See it? Think positive, right? Gratitude filtering into my positive graphs. So I'm going to rise 1, 2, 3, and run 2. Down 1, 2, 3, and run 2. So 3/2 x plus 2 would look like that. So let's finish part 2 together, and then we'll send the people that are going to pictures, and we'll do part 3 together when they come back, okay? And we'll be working on something else. All right, what would I do for part B? How do I get the y by itself? Well, this is a 1, so I'm going to divide everything by 3, right, to get the y over there. Y is by itself now. So 1/3 is the part that I think is tricky when there's no 1 sitting there. So I just like to write the 1 to remind you that there's a 1 in the numerator and the 3 is actually in the denominator because you divided by 3. So gosh darn, there's another positive slope. I start at 4 and I go up 1 over 3 and down 1 over 3 in the other direction. Oh my gosh, bad planning. I just kind of made up the problem, so. All right, we good on part B? All right. Part C. Oh, this one looks bad. How do I get the y by itself? 2 steps. I gotta first move the x to the other side by subtracting it, right? So then I have negative y equals negative x plus 2. But y is still not by itself. So I actually need to divide everything through by a negative, like dividing by -1. So you're just changing all the signs to their opposite. So now I have positive x and a -2 as my final equation. And what happens when there's nothing written there? What do I have to put right there for the slope? It's 1 over 1 is my slope if there's nothing in front of the x. All right, so I'm starting at -2 on the y-axis and going up 1 over 1. So from that point, up 1 over 1 in each direction. All right, you take a stab at D. See if you can do D by yourself. Maybe do it in pencil, but I have confidence in you. See if you can get the y by itself and graph it. And then we'll put the answer up in just a minute at the end of my video. So there's the answer to part D. Question? Sure. What were you confused on? Oh, okay. I'm not quite there yet. All right, I'm stopping this video.